All right, pre-calculus section 5.3. This is the fourth section, and we are still solving trigonometric equations. For this one, we are going to solve some of these by using the quadratic formula, which you will need your calculator to do this. And then we'll also solve some equations with multiple angles, and you'll find out what that means when we get to that section. We're going to start out with solving equations with the quadratic formula. If you did not have a teacher that sang the quadratic formula for you last year, I feel really bad for you, but I will do that for you now. Oh, here we go. So we always start with what we're trying to solve for. So usually in Algebra 2, it was an x, and it's to the tune of like Pop Goes the Weasel. Goes x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And that's for quadratic equations in the form of ax squared plus bx plus c equals 0. So what you notice is that it has to equal 0. Must equal 0. And has to be in the correct order, so you can find A, B, and C. Only what we are doing is not going to be with x's. It's going to be with tangent x, or cosecant x, or sine x. It's going to be something more than just x. So this specifically says we're going to solve these using quadratic formula. If I did not have directions and it was just solve them, then I would try to factor it first. And because I couldn't figure out how to solve it by factoring, then I would say, oh, maybe I need to use the quadratic formula. So we will set this up instead of x equals, I'm going to set it up as tangent x equals opposite b, so b is 4, plus or minus square root b squared minus 4ac all over 2a. So you'll see tangent x is equal to negative 4 plus or minus 16 minus 8, so 8 over 2. So I get tangent x equals negative 4 plus or minus 2 radical 2 over 2. I could factor out a 2 from the numerator and get 2 parenthesis negative 2 plus or minus square root 2 all over 2 times 1. If you factor the number out, then you can cancel it. Otherwise, you can't cancel it. So I have tangent x equals negative 2 plus or minus square root 2. Now, all of that, all of that stuff that I just did past here, I would say, all of the other steps I just did are just a quick review on simplifying using quadratic formula. It doesn't even need to be simplified for this because we're going to type it into our calculator. We have to solve for tangent, and in order to get rid of, we need to solve for x, but in order to get rid of the tangent, we will have to use tangent inverse. We'll have to do that to both sides of the equation. So really, it doesn't matter if I have the negative 4 plus minus square root 8 over 2, or if I have the simplified version. It doesn't really matter. Those are equivalent. We're just trying to solve to get x by itself. So now I will have to use my calculator here, and you will have to type in negative 2 minus radical 2. Oops, I'm sorry, I forgot about my tangent. Try that again. We will have to type in tangent inverse, -2 minus radical 2, and tangent inverse, -2 plus radical 2. We're going to have to type in both of those at separate times. So I have my calculator with me. However, because I'm not using the document camera, you can't see it, and I don't have one on the actual computer. So if you need help typing this into your calculator, please ask me. My calculator is in radian mode. So I'm going to type in inverse tangent -2 minus square root 2. And I get, let me move where I wrote radian mode. Actually, I put it over here. We'll call this one x1. There we go. So I get an x1 of approximately -1.2859. So our answers have to be from 0 to 2 pi, and negative doesn't fit into that. This would be 1.57, this would be 3.14, and this would be 4.71. -1.2 something is in this fourth quadrant, but we want the positive version of that. Also, tangent is negative in the second quadrant. So we've got two places where tangent is negative from 0 to 2 pi, and my calculator gives me the restricted answer, -1.2859. So that means my reference angle is positive 1.2859. And to get the answer in the second quadrant, I'm going to take pi minus the reference angle. And to get the answer in the fourth quadrant, I'm going to take 2 pi minus the reference angle. And the angle on my calculator is negative, so I really am just going to take that number and then add pi or add 2 pi. So I get my first answer as 1.8557. And then my second answer as 4.9973. And that is for x1 only. So we still have to answer for x2. So I have totally different, not totally, I have a somewhat different equation to type in for x2. I've got the positive, the plus version. So I'm going to go ahead and retype in tangent inverse. Only this time I'm doing -2 plus square root 2. And my x2 on my calculator gives me -0.5299. So that will be in this quadrant. It is a negative answer. So that means the other place that tangent is negative will be the second quadrant. Our reference angle would be 0.5299, the positive version of that. So I'm going to take 2 pi minus the reference angle here and 2 pi minus my reference angle in the second quadrant. I'm just going to use my calculator for that. And I will get for my x2's I will get 2.6117 and 5.7533. So since I have 4 answers, those will all go together. I am going to put them in order. I don't know if I said what to round to. It doesn't look like I said what to round to. Usually it's going to be 4 decimals. I don't remember what's on the worksheet, but we'll find out when we look at the worksheet. Okay, now I'm going to go ahead and just double check that I did this correctly by typing it into Desmos. Oops. So we've got tangent squared plus 4 tangent x plus 2. Oops. That is a crazy looking graph, but from 0 to 2 pi there are 4 answers, and I believe I remember the 4.99. I remember it was 1.8 something, 2.6 something. Hopefully those are correct. Desmos will only give you 3 decimals. Oops. Let's see, 2.6117. Yep. And then 5.753. Yep. So those are correct. Desmos is only going to give you 3 decimals, but doing it on your calculator, you'll be able to get more. All right. Let me do another one of those. Exact same directions. We're going to solve using the quadratic formula, but it's not in the right form yet, so I need to rearrange. And let's see, I'm going to add cosecant x, squared x to both sides. So we'll have 3 cosecant squared x plus cosecant x, and then I'm going to subtract the 6. And now we have it in quadratic form. So I will have cosecant x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Let's clean this up just a teeny tiny bit. -1 plus or minus square root, what do we got here? 1 plus, what's 12 times 6, 72, 73, all over 6. Okay, that does not simplify. Plus, like I said in the first question, we really don't need to simplify it for what we're doing here. We're trying to get rid of the cosecant and get x by itself. Okay, so what I really need to do is I need to do sine inverse. But sine inverse will not work next to cosecant. It only works next to sine. So instead of having cosecant here, we're going to reciprocate. But if I reciprocate one side, I have to reciprocate both sides. So I will be doing sine inverse, and I will have sine x. So I will reciprocate cosecant, right sine. On the other side, I will have sine inverse. If I have to reciprocate what's sitting there, which gives me 6 over -1 plus or minus square root 73. I'm not going to worry about a square root being in the denominator. I'm not going to worry about anything like that. I'm just going to type it in the calculator to find x. So we're going to have two x's. We're going to have an x1 and we're going to have an x2. My x1 is going to be sine inverse of 6 over -1 minus square root 73. And then my x2 will be sine inverse 6 over -1 plus square root 73. I'll pull out my calculator. I'm going to type that in. And my first answer is -0.6798. I'm just going to go get my other answer while I'm doing this. This is not a big deal for me because I have the newer calculator where I can just go get the answers from before. If you have those older calculators, you might not want to just do them all at the same time. Okay, so x1, let's change my color. X1, we see that it is a negative number. So if it is in this quadrant, sine is negative in this quadrant, it's also going to be in the third quadrant. Our reference angle will just be the positive version of this 6798, so positive 0.6798. To get the one in the fourth quadrant, I will take 2 pi minus the reference angle. To get the one in the third quadrant, I will do pi plus the reference angle. And remember, it has to be bigger than 3.14. This one's going to be between 4.71 and 6.28. So you can kind of double check that you're typing it in correctly in your calculator. All right, so pi. So this one is going to be about 3.8214. And then the second one is 5.6033. And both of those check off to where they should be in the correct quadrants. All right, so then we've got x2, and that's a positive. So that'll be right up here. And at 0.9196 is also the reference angle. So to get it in this quadrant, because that's where sine is also positive, I just have to take pi minus the reference angle. So my calculator, I'm going to do pi minus that answer that I got a while ago. So I have to go scroll up. And I got 2.2220. All right, so now I'm going to put these in order, and I'm going to double check on Desmos that I have them correct. Okay, so my original question was 2 cosecant squared x plus cosecant, plus cosecant x. And then the other equation, or the other half, would be 6 minus cosecant squared. And we are looking at where these two graphs intersect, where they're equal to each other from 0 to 2 pi. And we've got 1, 2, 3, 4 different answers. I'm just looking at the x's. I remember the 2.222. 0.92, was that my first one? Yep, 0.9196, so 0.92. Let's see, I'm looking for a 3.82 and a 5.60. 3.821, 5.603, that looks perfect. So I have the right answers. All right, so that is using quadratic formula. And then the last part of these notes today are called multiple angles. And I'm going to start out by playing around with Desmos. This is something that you could also do as well. So I'm going to do cosine, and I'm going to put a variable b, x. And b is going to be a slider. So right now we have the normal cosine graph from 0 to 2 pi. Let me put some lines. X equals 0 and x equals 2 pi, so that we can see. I'm just trying to change this color. So we can see those lines where it starts and finishes. Oh gosh. There we go. Make them purple. So we can see the lines where it starts and finishes. That's one cosine graph. Now, what I'm going to do is I'm going to change that b value. I'm going to put on a horizontal shrink and make it into cosine 2x. So I'm going to grab that b and I'm going to move it up to 2. So I did a horizontal shrink, which squishes it side to side. And what that did was it actually created more cycles from 0 to 2 pi. And the number of cycles from 0 to 2 pi of that cosine graph, that big valley, is 2. I wonder if that has to do with the b equals 2 or if that's a coincidence. So let me try making my b equal 3. And it's squished even more, and now I have 1 cosine, 2 cosine, 3 full cosine graphs from 0 to 2 pi. Something else that I'm noticing is right at the top where I clicked on the end of the first period and the start of the new period, it's divided, 2 pi divided by 3. 2 pi is normally the period. This is 2 pi divided by 3 because it's squished in so much. This one is 2 cycles, 4 pi, divided by 3. Now, if I use that same pattern, then this one here would be 6 pi divided by 3, and it is. Let's just do one more. What if b equaled 4? Now we've got 1 full cycle, 2 cycles, 3 cycles, 4 cycles. I said I want to do one more. I lied. I want to do one more. 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles. So that b value is telling you how many cycles occur between 0 to 2 pi. It is also telling you that denominator. And then what's happening as I go between each new cycle, my numerator for the x's go up by 2 pi each time. So I've got 2 pi, 4 pi, 6 pi, 8 pi, and then this last one would be 10 pi over 5, which reduces to 2 pi. So these are not coincidences. These are going to help us find these answers. Okay, so this is asking the x-intercepts. I was not looking at the x-intercepts just now. I was just looking at the maximums. So let me go back to make this at 2. You don't have to graph this on that graph unless you feel like you want to. So when I when I created the two full cycles in here, the x-intercepts are now at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Oh, we didn't do this one yet. Let's graph cosine 1/2. Let's change that to 1/2. And then between 0 and 2 pi, there's only half a cycle, and that one x-intercept is now at pi. So that is a horizontal, a horizontal stretch from 0 to 2 pi. There's only one x-intercept at pi. Normally our x-intercepts for cosine would be where x is 0 on the cosine graph, which is at pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2 would be the normal x-intercept. So with this second graph, it was a stretch. So we only have one x-intercept. All right, here's how we're going to solve these. First thing we're going to do is we're going to get 3x by itself. I'm going to get rid of the cosine, which these are non-calculator questions. So these should all be questions that you could solve. Oops, I didn't mean to do that. That you could solve using the stuff you had to memorize, the special triangles. Where is cosine? So I'm going to think about like maybe cosine u equals 1/2. I think about cosine u equals 1/2. So where is cosine 1/2? That's positive, so it's going to be in these two quadrants, and it's going to be at pi over 3, so 5 pi over 3 as well. So instead of having u, I'm just going to have 3x, and we're going to have pi over 3, and we're also going to have 3x is equal to 5 pi over 3. Now I have to solve for x, so I'm going to divide. Oh, I got to do something else first. I apologize. In previous version of the notes, we were talking about all the solutions. And that's where I added on the period of that graph multiplied by n, where n is an integer. N is an integer. Put it over here. I didn't really leave myself enough space to write it over there. Sorry. All right. So this would be like all solutions where if 3x was at pi over 3, then I could add on a full 2 pi, and it would make a coterminal angle at the same place. It would have the exact same answer. I could go around again and just keep adding on 2 pi's. Or we could go the other direction and take away 2 pi, and that would be like negative 2 pi, and that would still get me to the exact same location, but it will never get me to 5 pi over 3. So I had to have that other answer, that 5 pi over 3, adding on 2 pi as well. 2 pi or subtracting 2 pi, whatever direction I decide to go. Okay, so now going back to solving this. Once I have 3x equals, and I have my first answer and my second answer, and my other answer, and then I have the period, now I'm going to divide everything by 3, which is the exact same thing as multiplying by 1/2. I mean, sorry, 1/3. 1/3. So we'll multiply by 1/3 everything, or divide it by 3. And I get pi over 9 plus 2 pi n over 3. And I also get 5 pi over 9 plus 2 pi n over 3. So this tells us how to get more answers. One thing that we learned, hopefully, when I was doing those Desmos examples, is that the B number, this number right here, B equals 3, is the number of cycles between zero to 2 pi. And then the denominator, we divide by 3. We kind of saw that when we did the Desmos examples, and then you saw me just right here dividing by 3. So this is the way that I feel is the easiest, and you can do it, using all the real answers up here, or you can do it this way as well. It doesn't really matter which way you do it. But what I'm going to do is I'm going to solve for that pi over 3 and that 5 pi over 3 first. I'm going to solve, and I'm going to get my two answers. I'm going to get my x1 is pi over 3, and my x2 is 5 pi over 3. And I'm going to call this the first cycle. We know that there's 3 cycles. So my second cycle and my third cycle, I'm still going to come up with. To get to my second cycle, I would normally add 2 pi. To get to the third cycle, I would normally add 2 pi. Okay, oops, I went ahead of myself. Normally add 2 pi. So since this is the answer for x, not 3x, I'm going to go ahead and add the 2 pi by finding a common denominator, which would be 2 pi with a denominator of 3 would be 6 pi over 3. So I'm going to go ahead and add those. So I get 7 pi over 3. And then add 6 onto this one, I get 11 pi over 3. And then to get to my third cycle, I'm going to add another 6 pi over 3 onto my last answer. So I get 13 pi over 3 and 17 pi over 3. And then the last thing I'm going to do is these are the answers for x1, x2, but it's actually, I should have put 3x, sorry. These are the answers for 3x1 and 3x2. So now to get the answers for x1 and x2, I'm now going to divide my answers by 3, or multiply my answers by 1/3 since they're already fractions. So I'm going to take each of these and multiply by 1/3. And I will have the correct answers, and I'm going to go ahead and write those in order as I'm writing them. They should already be in order. I'm just going to multiply each one of them as I'm writing it. So pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. So that should be my correct answers. Now I'm going to go ahead and check this one with Canvas, and I also want to show you up here, if we had done it using these, we would have to have the common denominator. So I would take my 2 pi over 3, I'd multiply the top and the bottom by 3. So I would be adding on 6 pi over 3, so that would equal 7 pi over 9. And you can see that's the third answer there. So if I did the same thing here, I would be adding on another 6 pi over 9. Yeah, 6 pi over 9. So I would get 11 pi over 9. So you could do the same. You could do the first way or the second way, however you want to do it. But either way, you have to add 2 pi and divide everything by 3. Let's check this answer. I won't do the Desmos check for all of these because it'll take forever on the video. But cosine 3x equals a half. Okay, so I'm looking where cosine 3x and y equals a half cross, and we get all the exact same answers that we had doing it by hand. Okay. Next one, sine 2x minus 1. So I'm going to first solve for just 2x. So sine 2x equals 1. So 2x would be, let's see, where is sine equal to 1? Would be at just pi over 2. Now the 2 tells me 2 cycles. B equals 2. I have 2 cycles. We have to add on 2 pi in between the cycles. So if my first cycle would be the answer that I just got, pi over 2. My second cycle, I would have to add on 2 pi. But if I'm going to add 2 pi, I need a common denominator of 2, so that'd be 4 pi over 2. So my second cycle should be 5 pi over 2. And then that is the answer for 2x. So to get the answer for x, I have to divide by 2, which is the same thing as multiplying by half. So I'd have pi over 4 and 5 pi over 4. Now let me check that. Sine 2x minus 1. Oops. And from 0 to 2 pi, I've got pi over 4 and 5 pi over 4. All right, cosine 1/2 x equals 1/2. So when I see that 1/2 x, that's going to tell me, since b is a half, we've got half a cycle. So I'm going to take the first half of the cycle. So where is cosine a half? Cosine is positive here and here, half at pi over 3 and 5 pi over 3. But we're just going to take the first half of the cycle, so I'm just going to take the pi over 3. So 1/2 x equals pi over 3. And this is the only number that I have. So to get the second one, I'm going to have to multiply both sides by 2 to get, I'm sorry, not to get the second one, to get the actual x, multiply both sides by 2, and I get 2 pi over 3. That should be the only answer. Let's double check. Cosine half x equals a half. X. Okay, that's not what I want to do. Let's do over 2 that way. Oops. And then had to equal a half, so y equals 1/2. Oops. Equals 1/2. And from 0 to 2 pi, just at 2 pi over 3, do they cross? All right, last example, when you get x by itself, we'll start out by getting 3x by itself. So this is cotangent squared. So we have to square root both sides, put in a plus minus, and I get cotangent 3x is equal to plus minus square root 3. So we get 3x by itself by looking to see where cotangent is equal to plus minus square root 3. That's going to be all 4 quadrants. And that would be at the 30 degrees reference angle, which is pi over 6. So we've got all 4 pi over 6s. So my b value is 3, which means 3 cycles. And we're going to add 2 pi to each of them, and 2 pi with a 6 on the bottom is going to be 12 pi over 6. Yes. Okay, so our first cycle is pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi over 6. That's my first cycle, and these are all for 3x equals. My second cycle. I'm adding 12 pi over 6 for each of these, so I'll get 13 pi over 6, 17 pi over 6, 19 pi over 6, and 23 pi over 6. And third cycle, add another 12 pi over 6 on each of these, so we'll have 25 pi over 6, 29 pi over 6, 31 pi over 6, and 35 pi over 6. Okay, that's what 3x equals. So to get what x equals, we have to divide everything by 3. Or multiply everything by 1/3. So if I'm doing that, that's just making all of my denominators 18. I've got 12 answers. I'm going to put them in order. All of my denominators are 18. And this is the last example. So you can start your assignment at any point, but I am going to continue writing these answers out. There we go. I did it. So you can too. All right. I hope you enjoyed these notes. Like and subscribe. Just kidding. And if you're still listening, I don't know why, but if you're still listening, a little kitty cat came over here. Oh, you were purring a second ago. Well, she's not purring anymore. All right. Have a great day.